Because this movie is quite long, we've listed here the times that each pane is being discussed, so you can fast forward to any particular point in the movie if you're just wanting to find out about a particular pane within the dialogue. The Wall Sill tab in the Settings dialog allows you to create a variety of different wall sills that will be part of the WinDoor object even though they are actually part of the wall. You can get some idea from the rendered image here. You can create what are known as vertical face wall sills, where the face of the wall sill is vertical, and then you can have sloping face wall sills like this one here, and using a variety of settings that you can see in the dialog here that allows you to create different types of sills. Here we're using these settings to create a granite sill, for example. So you can use the numbers down the side here to figure out what each of the settings in the dialog will do. This option here, draw 3D lower sill, if you have that checked and you have a unit like this selected where you have an upper sill and a lower sill, then checking that option will also create a sill down here on the lower portion of the unit. The Wall Existing tab is for when you're doing alterations and additions and you want to indicate that a door or window has been removed from an existing wall, or a new door or window has been put in an existing wall. The first option, remove opening from existing wall, is shown in this example here, and you can optionally show the door frame and extend the wall repair job beyond the opening using the controls here. So also show dash door outline, show repaired wall in top plan view, choose the wall style that you're going to use, and you can set the amount that you want to extend beyond the existing opening to indicate that the brickwork has been repaired. For the new wall in existing opening, you can add a little bit of patch brickwork on either side of the opening by specifying the wall style and the left or right patch. And one final option in this here is to actually show the outline of the removed door or window in a 3D view, and you'll see that if we switch to this save view here, these are the same two windows. So here's the door showing as dashed, in other words it's been removed, and this is going to be a repaired piece of wall. The frame members pane allows you to control the size and a few other things of the frames of doors and windows. You've got separate control for the jamb and head and sill thickness, mullion and transom thickness, and for the depths of those various members. As well, you can control the shim gap, and these numbers here indicate down here what the various controls are used for. The one I'm going to indicate is the auto size jamb depth for multi-track sliding doors. You'll see that if you have this option selected, then if you increase the number of doors, in this case I'm going to change the number of doors from 3 to 4, the jamb is going to automatically adjust to the required thickness to cater for the 4 doors. And if we switch it back to 3, then it's going to reduce in size. So that's quite a handy option to leave turned on. If you want to create internal trim, then in the frame internal trim pane, you check the box to draw internal trim and then choose if you want to see it in 2D, and you've got various options for those there, or 3D. Now this trim is essentially what one would use for externally in probably a timber wall, timber framed wall, but internally you could use this on any kind of wall, but you know, it doesn't have to be trim. You can actually use this geometry to create a variety of things, appendages I guess to the door or window. You've got your various sizes down here, and the numbers here indicate what each of the options do in the diagram at the bottom. The frame external trim pane is fairly self-explanatory. At the top you choose which options you want to show, and then you choose whether you want to show them in 2D and or 3D. You've got your sizes down here, you've got the indicator numbers to the right of those, and that allows you to tell what each of these controls actually does. In the Sash members pane, you can set the size, width, thickness of the sash. And there are a couple other things here that I just wanted to talk about. The offset from the face of frame. So this allows you to move a sash inwards or outwards within the frame. Sometimes different styles of windows will position the sash differently within the overall frame, and that control allows you to do that. I'll talk about this one in a moment. The text here, for 3D text, allows you to put fixed glass and so on onto the window. It will actually print a little bit thicker than that, and you can put it on fixed glass and sash, and also on all windows if necessary. Now the maximum sash width is quite a handy one, and I'll explain this in a moment. You can apply it to fixed glass, fixed sash, and also to louver vents by checking these options as well. But by default, it will apply to any of the other types of sash operations. And currently, you'll see it's set to 900 millimeters. And here we have a combination unit that has a fixed glass pane here and a sash window here that is 900 millimeters wide. As soon as I make this wider, it will automatically divide this up into two. So this is kind of like saying, look, don't make any sashes wider than 900 because they won't work. So you can set that to what you want. So let's go ahead and just demonstrate this. So you'll see if I open the form dialog where I'm controlling that particular sash there, and you'll see that the opening width of the sash, not the actual overall, the opening width of the sash is 820, but let's say I move this up to 1200, and you can see in the preview here already that what has happened. And when we click OK, you'll see that it has automatically created two operable sashes in there. So this way, you can create a whole bank of operable sashes without having to divide it up, just using the maximum sash width setting. In the sash glass pane, you can control what is happening with the glass in Windows. The top section here controls glazing bars, so no bars, space bars, so the bar depth and width controls the size of the bars, and space bars gives you an even distribution of spacing depending on the spacing values that you put in here. Offset bars will give you up to 4 bars depending on these 4 options here that are offset by this amount from the edge of the sash itself. For either spaced or offset bars, you can decide to only have glazing bars in the top section of a double hung window. You can also choose not to have bars on fixed glass, and you can also choose to move the glass, any fixed glass, so that it aligns with the sash glass. Here we have the controls for the glass block size and also for the louver clip size, typically 152 or 102 millimeters. In the door members pane, you can control all of the aspects of the door within a WinDoor object. This includes the frame size for a glazed door, so the top rail, mid rail, left and right stiles, and bottom rail. You can also control the handle position, the louver spacing if it's a louver door, the pivot offset, so if you have a pivot door like this one here, and that's it in elevation, that percentage controls the distance from the edge of the door to where the pivot happens. The cavity sliding and wall sliding protrusion, so that is the amount that the door will protrude into the opening when it's fully open. The cavity sliding door-to-door overlap, so that is the amount of overlap you are seeing in this example here and also here. And then you also have the overlap of the door into the cavity itself. So in other words, the amount of the door, or the amount of the door that stays within the cavity. You then have the door jamb offset. This allows you to move the door within the frame so that it's not at one edge of the jamb or the other edge of the jamb. Show finishes line in top plan view. So this allows you to differentiate the finishes between, say, a bathroom and a timber floor or something like that, and actually draw a line there. Show 2D arc when the door opening angle is 0. So sometimes you will want to indicate that the door is, to show the door is closed in a top plan view, but still indicate using a dashed line that the door does swing open. And finally, the option here to create separate timber door components. Now, here's an example of a door that doesn't have separate door components and one that does. So you can see this one here, when a texture is applied to it, that the texture applies to the whole door in the same direction, going up the door like that. When you have this option checked, then the door will be separated out into its individual components. So in other words, left stile, right stile, top rail, mid rail, bottom rail. And for the top, mid and bottom rails, the texture will run horizontal to the ground, so that you'll get this kind of thing. And if it's a hidden line rendering, or you have edges showing in OpenGL, then you will get a line where the different components of the door join, like here and here, as opposed to getting no line there. The door glass pane is similar to the sash glass pane in that you can control whether there are glazing bars and whether the bars are space bars or offset bars. The one thing to point out here is that if you want to create this kind of effect where the glass might have a glazing bead around it, you can actually use the offset bars to do that by setting the size of the glazing bead that you want, and it will appear on each side of the door, and then setting the offset from edge either at 1 or at something very close to 1. If you set it to 0.1, for example, it will be virtually 0, and when you click OK to this dialog, and if you open it again, it will actually say 0, but 0.1 will be stored, and then so you can keep that number very small so that this glazing bead is flush against the actual edge of the opening there. The AS1428 pane allows you to check your design for access and mobility in accordance with the BCA and also this standard. And if you've ever looked at the standard, you'll be familiar with these pages here and the clearances that are required for the doors in such buildings. WinDoor is able to automatically display the clearances around doors so that you can check compliance with the standard. And here's an example of what it can look like. You can display the clearances with or without dimensions, and they are fully interactive. So you can see here that the clearance on this door is only 850. It needs to be 900, so we need to add another 50 millimeters to the door. And if we come here, door leaf width, and we just go plus 50, hit enter, you'll see that this is going to regenerate, and the size is now indicating 900. So let's now look at how you would turn this on for some doors in the drawing. So the first thing you want to have a look at is the settings dialog and the AS 1428.1 2009 tab, which you can see here. Just running through the settings here, we have the door thickness, and that is exactly the same as the door thickness here. Changing one will change the other. We have the jamb rebate, and that's explained down here or on this side. We have the hinge offset, the door leaf width, the clear opening. So this is just a readout field that's going to tell you what the clear opening is, so you'll know if you're complying. And the first thing you do then is to choose or to import the dimension standard. So you just choose this option here. That imports it for this object, and generally you'll want to import that for all other objects. And we'll click yes for that. Over here we have an interactive diagram where you can choose the approach for either side of the door. So repeated clicking will change the options. So let's say this is how we want to display this particular door. Now the AS1428 settings are going to appear in a few places in the interface. Another is in the classes tab, where you can set the class, and this was important because you need to set up the colors and line colors and things for this class so that the clearances display as you want them to. So we'll go ahead and click OK to that. And the other place in the interface where this appears is in this accessibility down here. So let's go ahead and turn this on. And you'll see by default that this has come in just with the default class settings. So let's go up here and edit those class settings. For the class, you can see it's now been created. So we'll use user creation. Now the background color here, you can set it to anything you like. I generally give it an opacity so that you can see through it to objects underneath. And the line color, or this color here, will control the dimension color and also the fill of the arrows. So I normally set this to something like that. Let's go ahead and click OK. And OK again. And we'll just turn this on to display lines and dimensions. And you'll see that this is now displaying as we've set up the class. So again, if we want to show that on this door everything's been set up, all we have to do now is to choose what we want to display. And that's going to come in with the default access directions on both sides. But again, if you needed to change that, you can come back in here and say, actually, this is being approached, say, like that. Do those clicks there, click OK, and this diagram is going to change accordingly. If you turn off the WD AS1428 class, then those objects are going to disappear. The Door Extras pane allows you to create vision panels, both rectangular, oval, and automatically centered, air grills, and you can specify the blade spacing, and kick plates. You can put them on one or both sides. And here's an example of a door with these three things on it. You then have another option here for door gaps, which allows you to create a space at the top and or bottom of the door, typically used in toilet cubicles. All of these options only work with flush doors. The custom symbols pane in WinDoor allows you to replace some or all of the geometry within a WinDoor object with your own geometry. Let's take a look at how it works. To get access to this, you first need to click the checkbox at the top. The first option here then will allow you to replace the entire contents, 2D and 3D, of the WinDoor object with the symbol that you create here. Now if you use this option, you'll still be able to put IDs and attach data and so forth to the object. It's just going to replace the actual door and or window geometry, not the other stuff. Second option allows you to replace just the door leaves, and you can optionally get WinDoor to still create all of the 2D door and sash geometry. And you have options here to flip the door in case the symbol was created the wrong way around, or there's an instance where you need it the opposite to how you have it. The next one allows you to replace the sashes in a WinDoor object, and again you can flip them over the wall, and that uses the symbol number 2 here. And the third one allows you to replace the nominated sashes, and you'll see that there's a new sash type that will use a symbol 3. It's called S3, so when you choose S3 as the symbol, as the sash type, as opposed to AH for ornate hung or DH for double hung, then it will replace the sashes where you've nominated them. And the idea of that is primarily to allow you to create two different types of glazing. So you could have obscure glazing at the bottom and transparent glazing at the top, for example. So let's have a look at how this will work with, say, doors. So let's go ahead and pick a door here, say this one, and we'll go ahead and click OK. The doors will be imported, and you can see that they've now been inserted in place of the standard WinDoor ones. Now when you're using doors like this, you need to build a symbol so that it's the correct size. Otherwise, it actually doesn't matter if you don't, but obviously the sizes of these internal members are going to become distorted the greater the discrepancy between the size you created the symbol and the size that you've actually got it. But regardless, if you make these doors wider or narrower or taller or shorter, the symbols will adjust. WinDoor will automatically adjust the symbols to suit the size that you create them. I guess another example where you might use a symbol like this is if you want a different color on each side of the door. There's probably lots of different instances, but let's take a look at how you actually create a symbol, and it's fairly simple. In this view, I'm just going to create a rectangle, and for what I'm showing you now, the size of it actually doesn't matter that much because it will just get scaled, and because it doesn't have internal components, or it won't have internal components. You'll understand why in a moment. So let's say I put that on one side, I duplicate it there, then make the other side a different color. So we've got these two different colors, and we'll go to a top view and convert this into a symbol. So modify create symbol. Let's call it, note that it has to start with WD hyphen in order to be recognized by WinDoor. Custom door, and we'll just go with all of those settings. Return to our previous view, select the object and click the settings button again, and this time we'll see our symbol there. This is the one we just created, so we'll choose that. Click OK, and you'll see that WinDoor has automatically scaled those objects, or that symbol, to be the size that's nominated for the door. So in other words, it's taken the door width, the door height, and also the door thickness here, 35 millimeters. So it's changed the thickness to be 35 millimeters. And you'll see that if we open this door now, you'll actually see the two components there, and you can see that one side of the door is blue and the other side is yellow, and you can actually see the join there, but you can see it's been reduced in thickness. So these doors are actually 2040 by 820 by 35. Now the same logic applies to creating a sash, but with sashes generally you're going to have glass in them, so you're going to want to make them a bit more accurately. So the nominated, or the recommended way to do this, let's go to a front view, and I'm going to just trace over this so let's say I want a sash. That's the outer part of the sash, so I know the size is right now, Now when you're creating these symbols, it's important that the symbol sits at 0 at the bottom. So we can click here, set that to 0. And I'm going to duplicate that as well. -80. Could have just used the offset command for this. So I've got my inner sash, but I want to have a curve at the top. So let's say the curve is something like this. So I've now drawn that arc. I'm going to add that. Right click, add surface. So I'll now subtract this from this, select both of them, clip surface. So this here is going to become my glass, and this will be the sash itself. So we'll extrude this to say 6 millimeters and put it in the WD glass class and extrude this to say 35. Put that in the WD sashes class, and we'll now jump to a top view and make sure that that glass is correctly aligned. We want it to be in the center of the object, so I'll just nudge it through to the center. So let's go ahead and create a symbol from that. WD hyphen custom sash. Click OK. OK, cycle back through the last few views to get to our 3D view. I'll get there in a minute. There we go. And in settings, note that this unit only has 3 sashes. It's fixed glass in the top and down here as well. So these 3 sashes are what we're dealing with at the moment. Replace sashes with, and here's our custom sash. Click OK. And you can see those custom sashes have been replaced. Now I can see I've made an error here in the placement of the symbol in relation to 0. Let's go in and take a look at that. Here's our symbol here. Right click, edit 3D component. I'll switch to a front view. And if I hover my mouse here, actually that is the 0 point. I can see it's 40 millimeters too high. So I'm going to select all of the components in the symbol, use the move command, move it -40 millimeters. And that has corrected that aspect of it. There's one other aspect of it that I need to mention, and that is you can see that these are actually protruding slightly out of the frame, and you do have to be aware and set the value for the offset within the frame for these sashes, and you do that in the sash members here. So this -10 value here, so we made the sash 35 millimeters and it needs to be offset. Half of that is going to be 17.5 -10, so it's 7.5 millimeters outside the frame here. So I'm going to need at least another 7.5, but let's say make this -20. That's going to put it within, just slightly within the frame there. So once you've got these sashes in here, then you'll see that if we use open in 3D, they're going to behave like whatever kind of sashes they are. So these are awning hung sashes, so they'll behave like that. Now the final type of custom symbol you can use is for glass. So let's go ahead and create a symbol for that. And what I'm going to do is it's only the thickness of this that matters. So I'll set this to 6 millimeters. and then we'll extrude that to a height of say 400. And this can be our little piece of custom glass. So let's give this a custom glass texture just so that we can recognize it as being different. Let's go with glass blue. It's not that obvious, so we might just edit that glass texture and change it to color. And let's just pick a color that's a bit more prominent. So it looks a bit darker. So this is our piece of glass. So now we need to make this into a symbol. So modify, create symbol, WD custom glass. Okay. So now we want to use that custom glass in these panes up here. So firstly we need to just say that we're going to be using that custom glass. So back in the settings dialog, in custom symbols, replace selected grid openings. Let's choose our custom glass one. Click OK. Then in the form dialog, we'll want to set these to S3 symbol 3. Click OK. And you'll see now we've got different colored glass in these top panes up here compared to the other glass that we've got. And that way you can have a variety of different glazing options within the one WinDoor object. The classes pane gives you control over the 2D and 3D components of WinDoor objects. By default, the 3D classes are preset, and the 2D classes are largely using the WD 2D class, except for the WD ceiling, ID, loci, and AS1428. If you open one of these menus, you'll see at the top here a suggested name, so WD 2D frames if you did want to class the 2D frames, and doing this would allow you to control line weights and colors by class rather than by using the Pens and Colors tab. An important aspect of this tab is that in any document, if you have this set to use and edit master class prefs, then changing these settings for any WinDoor object in the drawing is going to change them for other WinDoor objects in the drawing. So this saves you from having to coordinate the classes between all objects. Having said that, there are cases where you want to possibly use a specific glazing class because you want to have obscure glass in one particular unit or something like that. And so you can switch to using unique classes for this object. And when you're using unique classes, when this option here is turned on, then changing the classes for the particular object that is unique is not going to affect the classes of other objects. So usually it's a combination of both. This option here allows you to, if you have been using unique classes, to switch those unique classes to master classes and therefore affect all objects. When you do change the classes in here, it's worth noting that it won't automatically regenerate other objects. So if you were to change this to, say, WD frames, initially it will only affect the particular object you have created. So if you want to update all of the other objects to also have WD 2D frames as the 2D frames class, then you would click this option here, Update All WinDoor Objects. The Pens and Colors pane is where you can set the 2D and also the 3D line weight, pen color and fill color. It's fairly self-explanatory. You just choose the line weight that you want, or if it's not listed there, you can choose the set thickness option. Some of the drop downs will have also the option to choose a dash style. For example, in the direction arrows, the demolition line weights and the reflected ceiling plan doors. Fill colors don't apply to everything. Obviously direction arrows don't have a fill, but things like frames and doors do have a fill. So you can choose those options as required. By default, and just like in the Classes tab, you have the option to use a master set of pen preferences that will affect all window objects in the drawing. And if you want to have unique pens for one or more objects, then you can switch to using unique pens and colors for this object. And when you do this, making changes here won't affect any other object in the drawing. When you are using the master pen prefs and you make a change, you need to check this option here for that change to be reflected in other window objects in the drawing. It's worth noting that if you are using classes and you have those classes set to use at creation in the Edit class dialog, then the pen colors and thicknesses that you have set for that class will override the settings in this dialog. If you're wanting to produce IDs on your drawing, either in plan or elevation, or produce door or window schedules, then you will need to familiarize yourself with these three panes in the settings dialog. We'll start with the ID symbols one, because this is really the starting point to placing IDs in the drawing. And in this dialog, you choose the symbols you're going to use and set up a few other things that I'll explain in a moment. I will point out that all of the items in this dialog, and in fact the whole settings dialog, has a fairly comprehensive help text at the bottom here. So if you're wondering what something does, what the effect of turning something on or off is, then read the help text down the bottom here and you'll get a pretty good clue about it. So we have separate controls here for doors, windows, combination units, and a fourth one for other IDs if you want to have a fourth shape. And these IDs can contain either a single line of text, which is typically just the ID, or two lines of text, and the second line of text can be, things like unit width, height, door size, or anything from the scheduled data tab as well. So just to expand on that a bit, let's say we have chosen a two-line ID and we'll use the second ID for the unit width by the unit height. And you'll see that that text will get entered in here, so that's what you'll see in the ID. Let's click OK and watch what happens when we do that. So you can see the problem is that the ID isn't big enough to fit that in, but you can take care of that in the ID. If we go back in there again, and if we scale the width by say 2, scale the width only, note that you've got width, height, and text. Generally you're only going to need to scale the width. Click OK and you'll see that this will then expand and be able to fit that that information in there. It's also worth noting that you can enter custom text in this field by choosing the custom item from the list, and then you can type in any text you like. You know, if this is a special unit or you want to make some comment in the ID, you can do that. And you know, when you click OK, you're going to see that that text is going to appear in the ID. And as I mentioned before, you can also pull in any of the custom fields from the scheduled data tab here. So, you know, again, these can be fields that you enter text for, or they can use some of the preset values in here as well. So if you want to customize the appearance of any of the IDs, you can either do this in the file you're working on once you've placed some IDs, and you'll see the IDs are just symbols. Here we are in the active file, which is called WD17 Settings, and in here is a folder called WinDoor ID Symbols. So anytime you use an ID symbol, WinDoor will create this folder and put the symbols in that folder. So if you want to edit one of the symbols, you can just locate it here in the Resource Manager, choose Edit 2D Component, and we'll just do a Fit to Objects, and you can see here that it's really just a simple circle, some text, and a line. So if I want to change the font, for example, I could come here and choose some other font. Let's say I wanted Arial narrow, for example. Then I could do that, exit out, and I'd be done. Just be aware that if you change the shape of the container for the ID, that it's a good idea to not have it as solid, because that can present problems with center front and center back. The text can sometimes not get displayed, so it's best if that doesn't have any fill. Now the file itself, in other words where these symbols are drawn from, is the WinDoor ID Symbols file, and I'll show you where this is in a moment, but this is basically just a file that contains all the default symbols, so that if you want to change these for future projects, then you can come in and edit this file and save it out to your user folder, and then your edited or custom IDs are going to appear in the list within WinDoor. Now this folder, or this file I should say, exists in this location. So here we're looking at the contents of the Vectorworks 2017 folder. So on a Mac, this would be in Applications, and there's the Vectorworks program. So on a Mac, it's in Applications. On a PC, it's in Program Files, and then the folder is called Vectorworks 2017. So then you expand Libraries, Object Styles, WinDoor, IDs, and here's the file that we were just looking at. Again, if you are going to customize any of these, then it's a good idea to save the custom file to the same location in your user folder. So getting back to the actual ID Symbols tab, you can set the prefix, so we'll leave it at DOW. You can have a suffix if you want to, and when you're happy with your settings here, note that we're using 1 leading 0, but you can have either no or up to 2 leading zeros. Then what you do is to click this button to apply the symbol settings to all the objects in the drawing. So this saves you having to set this up for every single WinDoor object. So you click this button, then you click yes, and that means that the settings in this dialog have been applied to all the IDs in the drawing. So once the symbols have been selected, you can then start numbering the doors and windows. And you can do this either one by one or in a much easier way using the WinDoor ID tool. So what we'll do is to place the IDs using the ID tool and then come back and look at this pane in the dialog again. The ID tool is in the DIMS Notes toolset, and this is it here. So when you select that and click the Tool Preferences button, which you need to do, you can then set the starting number for doors and the starting number for windows, and also for combo units and other units if necessary. And you definitely want to leave these first three on, automatically set the on schedule choice. So down here in the object info palette, this one will need to go on the window schedule. So that needs to be set, and the display plan ID and optionally display elevation ID, you probably want to turn both of those on as well. So this tool will do those three things automatically, and then you have the option for it to center the ID off the window object, which is a good thing to do. And you can also set the offset distance, and let's set that to say 650 millimeters. And then we can just go around and number the doors and windows by clicking on the window object and then clicking where the ID is going, and it's going to automatically center it and put it the nominated offset distance. So you'll see here, if I click on this one, and even if I click right up here, it's still just going to place this that set distance and center it over the door or window. And note that I can go from window to door, and the tool automatically recognizes this is a door and that's a window. So let's proceed around the drawing here. You'll see these are incrementing the windows, and we'll do the outside ones first, because it's likely the doors inside you actually want to have the ID in the center of the door here. So click on the settings button again, and this time uncheck this use fixed offset distance, or alternatively leave that on and set this to 0. And when you do that, you'll find that you can just click twice in the one place essentially, and these internal IDs will get created. Now I can click on any part of the door, so I could even click on this part here, do my second click there even, and the ID is still going to appear in the center there. So now that we've got all of the IDs placed, let's just have a quick look at the tool, and you'll see that in the settings dialog these have incremented up here. So if you do some numbering and then come back at a later time to do some more numbering, you can always come back in here, look where you're up to with the numbering and set this up. Or if you had to start the numbering in another drawing at a certain location, you can do that with the tool. So once we have the IDs, then let's take a look now at the settings dialog again. And you'll see now that this was a window that I clicked on. So all of the window IDs are listed here, starting at 15, and the one that is currently selected is the one in bold. The other ones are grayed out slightly. And you can change the order of these. So the one I selected was this one here, but let's say for some reason you wanted to swap this number here with 15, then I can just come in here, click in this 16 column on this one that I've selected, drag that up, and then click Update IDs to match list, go yes, click OK, and you'll see that the IDs on this one is now 15, and the one down here is now 16. Now this is also useful if you insert an ID. Now let's say you insert an extra door or window somewhere, and you want to insert an ID there into a set of existing IDs and push all of the other ones along. So let's say, for example, that we put another one of these doors in just here. And what you're going to see when I do that is that this is going to get the same ID as this one here. And let's now take a look at the settings dialog. And in the Numbers tab, you'll see that there's two red numbers here indicating that these two doors have the same ID. And that's kind of like a flag. Okay, so I've got to do something about this. So this is the suggested list. What it's saying is, okay, let's name this one here number 5 and then increment all the other ones up by 1. So we can click update IDs, yes, click OK, and this is going to increment up to number 6, and all of the other ones have incremented accordingly. The Schedule Data tab is where you can add additional information to doors and windows that you want to appear in a schedule or perhaps export via IFC. The tab contains 24 fields. The first 4 have fixed names: manufacturer, model, glazed area and vent area, and then there are 20 user definable fields, of which these 4 here can be used if you're wanting to put numbers in here that you're going to use for calculations. The other ones are text fields. The glazed area and vent area are automatically calculated, so if you want to put them into a schedule, then you can do so very easily just by listing those as the formulas in the schedule. The user fields 1 to 20 have names that can be customized, but the customization is purely for this dialog, so that you know that this might be leaf height, leaf width, thickness, hardware, whether it's got an insect screen, type of glazing, comments, and so on. And this field here down to here are ones that I've entered in there. So typically, or sorry, by default, this is user 1, user 2, user 3, user 4. So to customize the name of any of these fields, you just click here and put the use that the field has. In addition to being able to customize the names for convenience, you can also or automatically populate some of these fields with values. So you'll see here by default these are generally on enter value, where you can just type in some value in here that you might want to use in that field, or as is the case with these ones that I've customized, leaf height down to thickness, I've switched it to preset value, and in the preset values I've got door height, width, thickness, door height by width, and the other ones that you can see here. And the advantage of this is that these values are parametric, so that if the size of the door or window changes, then these sizes are going to update. So they're not manually entered fields. And even if I were to change this to something different, when I click OK, WinDoor is going to automatically pre-populate this with the actual size. So that's what we can do here. Now it obviously could be tedious going through every single window object and customizing these, so I'll show you how you can enter these once and then send them out to all of the other window objects. Now the other thing I wanted to mention here is the set custom type name for schedule. Now in the schedule you can typically use abbreviated names for door and window functions, for example AH for awning hung, or DH for double hung, or hinged, left, HL, and so on. So you can use either the abbreviated name or you can use the long name, and the long names we have pre-populated, but sometimes these are not appropriate for what you want or mightn't be exactly what you want. For example, this is a set of French doors and the automatic name that's being generated here is hinged left door. So probably we would just want to call this a hinge door. And the same might apply to the other doors as well, any other hinge doors that there are. So if you do want to come in here and customize this, so this is a folding door, so you might just want this to say folding, not folding door, for example, or sliding instead of multi-track or parallel sliding left or right. So you'll see that we can customize these in a moment. But right now we're just going to set this one to hinged, and we'll go ahead and click OK. Then look at the schedule. So we've got this here, and you can see this is what I was just talking about: hinge left door, parallel door system left, and so on. So this one here just got repopulated into the object, so we need to recalculate to just have that word hinged feed down into here. And you can see now that this says hinged, so that's the one that we have customized. These other ones are just using the standard names. So if we go over to leaf height and click in this field here, so this is the user 1 field that we customized to say leaf height. This is the user 2 field, so in the formula we've put underscore underscore user 2, and that's automatically populated with the leaf width. The thickness, the glazed area, is automatically generated, and then these other ones over here are just ones that we can enter information into. So the first thing I'm going to show you is how to get these showing up in the other doors as well, and also in the process allowing us to customize these values. Because this is being automatically generated, even if I try to change it here at this point, it's not going to change. And the reason for that is, if we look at this in the settings dialog, this box isn't ticked, so you can't customize them in the worksheet unless this box here is ticked. So going back to our original object where we put those custom values in, let's now click copy and apply styles, and choose to copy from the selected object, apply to all doors, perhaps on the active layer, and what we want are the schedule data labels. And when we click OK, those custom labels that we entered into this object are now going to be in all of the other doors and windows on this layer. So if we click here on settings, you'll see now that this has leaf width, leaf height, thickness, hardware, screen, glazing, and comments copied into it, and it's automatically populated those with the same fields. So leaf width 6 by 600, leaf height, thickness, and so on, and it's also checked this box here, so that means that now we can just change this to say folding. So again, let's take a look at the schedule. We'll just recalculate this, and you'll see that this is going to change to folding. So again, because of all these are now customizable, because we checked that box, I could change this to sliding if that's what I wanted to have there. And you'll see that it changed then. Now, you'll find that it can be slow working with a worksheet that has images in it like this. And this has doors and windows in the same worksheet. And the formula that causes an image to be placed into a cell here is a very simple formula. It's just equals image. If we delete that formula just while we're editing the worksheet, you'll see that these are going to disappear. And I'll do it for this as well. Click the tick, hit return. So now the updating of this worksheet is much faster. So while I'm entering in custom values, then I can have those not recalculating. So each one of these is actually a little viewport that renders, which is why it takes time. So again here, if we had some hardware sets that we wanted to put on these, so this could be HS 1, 2, 3. So that's going to feed that back into this particular object, D5. And if that hardware set is being used on other doors, I can just copy that, copy from the keyboard, and then just select the other doors that it might apply to, and right click and choose paste, or just paste from the keyboard, It's hardware set 1, 2, 3 is going to populate into those. So the same applies to screen, glazing, and comments. So you can very quickly come down here and populate the values in here, and you'll see now if we were to, and I'll show you something else you can do. So this is D6. If you're not sure where D6 is on the drawing, you can right click in this very left hand cell here, choose select item, and you'll see that D6 has been selected on the drawing and put to the center of the drawing, and you'll see that that hardware set, there's the value there, it's been put in here. If I change this to 1, 2, 3, 4, clicked OK, and open the schedule again, did a recalculate, it's going to change to 1, 2, 3, 4, which you can see there. So the same thing applies with the windows. If we look at the fields here, so for Windows we're using the user 1 field for hardware, manufacturer, model, screen is user 2, glazing is user 3, and we've got a comments field there. So let's just have a quick look at this particular window. We'll go select item, and it's this one here. Click on settings, and you'll see that we have those fields here. It's pre-populated with LIDCO AH4015. Hardware, screen, glazing, frame are the items that we've got here. Again, if you want to have the custom names, instead of saying awning and hung window, you might just say awning or awning hung. Click OK. Looking back in the schedule, we'll just do a quick recalculate, and this is going to change to awning hung, and this was actually frame. So frame type, in other words. So again, we can do the same thing we did with the doors. If we want to copy the settings from this window to the other windows, we come here to copy and apply styles, and copy from selected, apply to all windows, active layer, scheduled data labels. And if you did want to copy the actual data that's entered in those fields, you can check this box as well, but we don't want to do that at the moment. We'll just click OK. And now we have, so let's just randomly select this one here, select item, it's this one here. Let's go in and see if those labels were populated, and you can see they were hardware, screen, glazing, frame, and it's also checked this box here. So that means that we're good to go now to start populating these fields. So if all the windows were, say, LIDCO, then we can copy that, then select the other ones, right click, choose paste, and it's going to put LIDCO into those other ones. If they have the same hardware sets, then obviously you can do the same with that. Any similar model numbers, you can do the same, and so on. So once you're done, you've got all the information entered, and again we could do the same with this, because these are now set to using a custom value. These are all awning hung windows, so rather than going through each one of these and changing it, I can copy this one, select these other ones, right click, paste, and those ones are going to change. So now we can put the image back in here. You can either type equals image yourself, or you can go insert image function, and that is going to automatically put the correct formula in, and these are going to populate. And if we go down and do the same for the doors, image function, it's going to stick equals image in there. And finally, we can uncheck database headers, and we're pretty well good to go. In Vectorworks 2017, you're now able to nominate the height of the cut plane for 2D top plan drawings, and we've added support for this in WinDoor 2017 too. So here we have an example. We have a window that is above the nominated cut plane, which is set at 1000 millimeters, and we have a window below the cut plane. And in WinDoor, you can nominate differently how these two windows behave. You can also nominate differently how objects that are very close to the cut plane that you may want to just display normally, and also how objects that are a long way away from the cut plane are displayed. So let's take a look at this in WinDoor, and in the settings dialog in cut plane, you'll see that when cut plane is in use, which it is for this layer, the elevation here is grayed out because it's being set by the layer. So here we have objects above the cut plane. You've got three choices there: normal, 2D, wall break, simplified, and just a locus. And you've got the same options for objects below the cut plane. Objects that are just outside the cut plane, you can opt to include them or not, and you can also specify a distance for objects a long way away from the cut plane that you don't want to appear at all. So let's have a look at the top plan view of this, and note that there's a little wall here as well that's about 600 or 700 millimeters high. So here are the two windows. This one here that was below the cut plane is not showing at all. The one that was above the cut plane is showing as a dashed line, and you'll notice that this wall here is, even though it has the same wall style as this cavity wall here, it's not showing the cavities because it's below the cut plane. So for example, if I was to put this, change the height of this wall to say a meter, you're going to see that the cavities will appear in that. If I select this window here that I know is there, that's below the cut plane, and I change its position in the wall, let's put it to 1200, you'll see that it's then going to appear.